Okay, and I believe, I'll wait a second to believe. Okay, and I believe and hope that we're recording. And um, so this is a practice problem for regression. I will, in the folder for week 6, have this handout as well as the spreadsheet. And this is just a very simple regression problem. And first, let me preface this by saying what we're trying to do in regression is understand the magnitude or estimate the slope of the relationship for between a causal variable and a response variable. So in my little exercise here today, we're just doing this for for whether cigarette taxes discourage smoking. And so I have, as you see here in the table, a column of cigarette taxes, and I have a column of how many folks, what percentage of adults smoke. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, just 10 observations. So that's to make this a little bit more compatible. But if you want to follow along with and print this out, you can, because then the second thing I have it will be posted as well as the practice problem, and you can follow along. Perhaps let me do this and then see if you can do it on the practice problem with just the audio on. That might be helpful. So the first thing we're going to need are the averages for our causal and response variable. Our cause variable is the cigarette tax. Our response variable is the percent of adults who smoke. So to get the cigarette tax here, I can just do an equals sum, and then from D3 to D12, it looks like. And then if I close my parentheses, and then I want to do that, I have 10 observations, so to get the average, I just divide that by 10. You can use the average function if you want. Here, it's even easier because I've already sort of done it. If you put the equal sign in front of the little formula, you'll have that. So on average, 19.05% of adults smoke, and we see that the average cigarette tax is approximately $1.83. Okay, now we need to move to the regression equation, which requires several components. We have to first of all know the difference between the cigarette tax in each state and the average. And so what this requires us to do is say equals, and I'm going to put a dollar sign so that it's always the cigarette tax. Actually, I'm sorry, I just misspoke. The cigarette tax is actually in the next column over, so let's go ahead and just do that. I think I've got a few too many things going on here. Okay, let's start with this. And if we say equals, and we can actually make it just, if we put it in, and since we always want to stay on column D, and then minus $D, $15, that means every time it will take the $1.83. So this tells us that $3.40 minus $1.83 is $1.57. What we can do now is simply copy that formula and run it down to the line G12, and that will give us the 10 differences. So we can see that the 37 cents from $1.83 is the difference of $1.46. Over here, we can do the same thing to get the difference between the percent of smokers in each state and the average percent of smokers. And then we can simply copy and paste that. And that gives us then the individual differences between the percent of smokers and average percent. What you'll notice is that about half of the observations are below the average and half are above. That doesn't always have to be the case, but in our case, just about works out to be that way. The next thing we want is the cross product of the two, which this is, in other words, saying we want to know what this difference is times this difference. And this is going to form the numerator of our slope, which is the change in Y, the percent of adults who smoke, given a $1 or 10-cent change in the cigarette tax. In our case, it's actually a dollar change. And so that just requires that we multiply the G column by the F column. And whoops, for some reason, perhaps, well, a couple of things could have gone wrong. One is that I just don't have enough space. So I'm going to format my cell to 2 decimal places. Go to Format Cells, Number, and do 2. Let's see if that cleans it up. It did not. So what am I doing incorrectly here? Let's just try it again. Equals times G3. Okay, that time it worked, and it gave us $5.73. And so now if you do the copy and paste, whoops. And it will give you, and you'll notice that the largest product is negative 11.72. The smallest product is 0.11. The next thing we want is we want to know for the bottom, we want the independent variable and its differences yes, and this difference to be squared, and this will give us the denominator for our slope. And so again, this would just be G3 squared. Which we see $1.57 squared is about $2.46. We can copy that and paste it in here. Okay, now what we need to do are we need the sums of these, because the sum of the cross product divided by the sum of the squared difference, or mean difference, will indeed produce our estimated slope. And so coming here, we would have equals the sum of from H3 to H12, and here we would have the we would simply want to, if you want to, you can copy and paste this formula. Okay, and now to estimate the actual slope, what we have is we want to take the cross product and divide it by the squared difference of the independent variable. And so that would be cell H14 divided by cell I14. And it tells us that we have a slope of negative 2.032. Again, I'm going to go ahead and format my cell here because it's such a long number. I'll format it to up to 2 because, yes, sorry, there we go, to 2. There's rarely any occasion where you'd want to go beyond sort of 3 decimal points. So what does this tell me? Well, it tells me that for every dollar that cigarette taxes increase, the smoking decreases by 2.03% of the population. So a $3 cigarette tax should decrease smoking by about 6.09%. Now I need to estimate the intercept, which is sometimes called B sub 0. And that simply requires that I take the average number of smokers, which is the average of the response variables, and subtract it by B1, which is cell F16 in this case, by I'm sorry, this is the slope B1. So F16, yes, that's when I said B1, I didn't mean the cell, I meant the beta 1, the slope, minus the average tax, which is $1.83. So this then can become, and I have it here, and so let's just go ahead and plug it in here, which is C15 minus the quantity F16 times D15. If everybody has a chance to see that, then that's going to tell us what our regression equation is, and that's 22.77. What that tells us is that if there were no taxes at all, we would expect 22.77% of a state to be smoking. And then it also tells us we have a downward slope to the regression line. And so if I'm just going to go ahead and put it in over here as a full equation, since it's kind of nice and boxy, and that is that percent smokers equal, sorry, equal 22.77 minus, or it's really plus a negative, plus a negative, so it's easier just to say minus 2.03 times the cigarette tax. And how I would interpret that then is that, again, if the cigarette tax were 0, I would understand that that if there was a place where nobody smoked by some miracle, the percentage of smokers predicted would be 22.77. If the tax were $1, or let's say it's 50 cents, then it would be 22.77 minus 2.03 times 0.5, so that would be 1.015. And I would predict that about 21.72% of the population would smoke. If there was a $4 cigarette tax, then that's simply 4 times 0.203. I would say 22.77 minus 8.12, and so that would be 14.65. So I'll even give that. For some reason, my printing isn't cooperating. Let's go down one here. Be 14.65% smokers. Okay, and so this is just a brief example to walk you through the mechanics of it. I will have more to say about regression and the elements of regression, but I hope this gets you off to a good start. And again, all three, there'll be the practice sheet, Excel sheet, there'll be the practice sheet, Word document, and now there's this video as well, and I'll be giving you the link to that. Okay, so thanks very much. And as soon as I can stop my recording.